Yuri, your head's spinning? Why was your head be spinning? Oh, he's been practicing all of his moves for rotation versus revolution. Yuri decided he didn't want to draw any pictures. So what he's doing is he's just going to kind of show you rotations versus revolutions, and we're going to go through some of the differences that you'll see on Earth for because the Earth spins. What do we see happen because of that? And because the Earth revolves around the sun, what differences do we see happen because of that? So Yuri, what's a spin look like? All right, so a rotation or a spin is just when you're kind of sitting in place and turning around. You got any magic to show us something up there at the same time, Yuri? Now would be the time. So the Earth spinning, the Earth turning on its axis, that's a rotation. So different things, short-term changes. You see the sun rise and set. Maybe that might be happening over here, or the moon rising and setting, or the stars going around in a circle on a time-lapse picture in the sky. So Earth spinning. How did we test that? This guy a long time ago named Foucault, I forget his first name, he made this pendulum that goes back and forth and it knocks over pegs, and that pendulum looks like it turns different directions. In the northern hemisphere it will turn to the right, and in the southern hemisphere it will turn to the left, because the Earth underneath it is spinning. So since the Earth underneath spins, everything that moves above it looks like it takes a turn one way or another. So you can see that picture there. And it doesn't matter which direction you're turning. If you're in the northern hemisphere, everything's to the right. You're in the southern hemisphere, everything's to the left. September leaves need raking. SLNR. That's how you can remember that. So when we look at those pictures, there'll be some different questions you answer based off of Foucault's pendulum, Coriolis effect. That's the evidence that the Earth is spinning. Also, any short-term changes. If it's an hourly change, a nightly change, a daily change, that's because the Earth is spinning. Now the difference, the other motion that's happening is that the Earth is rotating. So the rotation looks like that. Yuri can demonstrate that by going, bless you, going around. Whoa, pause. The old man's losing it. I accidentally said rotation. This is a revolution. Revolving is when one thing goes around another thing. So the moon revolves around the Earth revolves around the sun. Don't get that confused with rotate. Rotate is spin in place. The Earth spins, the moon spins, the sun spins. All those things spin. When you go around another object, that's a revolution. So the moon revolves around the Earth revolves around the sun, and Yuri, his life revolves around rocks. That's a revolution. That's an orbit. That's a long-term change. On Earth, that takes a year, 365 days. So if you're talking seasonal changes, longer-term things, month-to-month differences, that's a revolution. That's an orbit. Okay. So other things that come into play with that, you can see different stars during the year. We have seasons. We've done a lot with that, but different stars, different times of the year is another big question that shows up. We'll go over some of those. You also need to locate a couple constellations. Usually it's just the Big Dipper, the Little Dipper once in a while, and locating where Polaris would be. Here's a picture that shows that. And so you can see you just line up those two stars, and that will point to where the North Star is, and that's how you can find your way north if you're ever lost at night out to sea in a ship or something like that. So if we forgot anything, we'll be back here, and if not, make sure you post comments, questions, and Yuri will try to answer those for you. And if he can't type, I'll type in his answers for you. Great job, Yuri. High five. Hope your head's not turning on its axis anymore. Okay, so let's go back and forth on some different rotation versus revolution things. And we'll just try to navigate what's a rotation, what's a revolution, and look for those keywords. Anytime, this is automatically, you see the pendulum, you see the word Foucault, you see Coriolis, it's automatically an Earth rotates and Earth spins question. Okay, so those are really straightforward. They can ask them in as many different confusing ways as possible. You see Coriolis or Foucault, rotate and spin, it's a gimme. So the path of the Foucault pendulum, I stop reading right there. The only thing I see is that it rotates. Okay, so very straightforward questions there. I like to see the test start out with those. We've got a picture right here. My first thought, I'm seeing the Earth orbit around the sun, but I don't know. It could be a confusing. Sometimes they try to misdirect you. What event is caused by the Earth's revolution? So what's happening when you see this diagram here? Your first thought for me is that it's seasons, but I don't see that as a choice, unfortunately. So I'm looking for anything to do with long-term changes, seasonal or yearly changes. A and B don't show anything. C is rising and setting of the sun. That's a daily thing. So D is throughout the year. That's my main thing there. Anytime you're seeing yearly changes, long-term changes, that's a revolution, or sometimes they'll call that orbit. We see that Foucault pendulum again, and for this one, you've got to pick what are the next pegs that are going to be knocking down. Automatically, I'm thinking to the right because we live in the northern hemisphere. If they had said in Australia or in the southern hemisphere, it'd be to the left. But if we're rotating, or if we're swinging here and the Earth is rotating, the next two pegs to go would be this one and this one. So that would be a right-hand turn, which looks like these right here are getting knocked down to the right. So that would be choice D. And just remember, it would be the exact opposite in the southern hemisphere. Predictable change in the direction of the swing of Foucault pendulum, Coriolis, rotate, spins, turns on its axis, sun rotates, well it does, but that's not a Foucault pendulum thing. Earth rotates, so choice C there. We've got another things turning, that's the Coriolis effect. Okay, so the path results from the Coriolis effect. And you just got to remember, this right here, even though it's going to your left, you've got to be the ball, you've got to be the curve. That is turning to the right. Okay, if we were in the southern hemisphere going here, it would turn to the left. See another picture of the Earth orbiting the sun, revolving around the sun. What's the evidence that the Earth revolves around the sun? So you're looking for a long-term thing. This is almost an identical question to what we saw a couple questions ago. There's only so many ways they can ask these things. So hopefully they even picked choice D again, different times of the year. Okay, two other questions here. Planetary winds deflect. September leaves need raking. So south to the left, north to the right, northern hemisphere to the right, and that's a Coriolis effect thing. Shout out here, throwback to a different review video. Doppler effect is Big Bang Theory, universe expanding. Evidence the Earth rotates, Coriolis, Foucault, automatically. Now I would read through this whole thing, but it's a gimme. Got another one here, a little bit different way of asking this. Okay, it's asking you to pick out which ones. Okay, ocean currents, the winds, everything that moves turns. North to the right, south to the left. Which one of these is showing north to the right, south to the left? Okay, that's making left-hand turns. That's making left-hand turns. That's a right. This is a right and a right. This looks to the left and to the left. So all of these, this is a left turn. When I draw this, this is a left. You can trace these things out right all over the test. Turning to the right. If I draw the arrow, I'm turning to the right. That's my choice. So right all over that test. And to me, it helps with something like this. What's a right hand? What's a left hand turn? I draw the arrow and it helps me make more sense of it. Got some more things here. Which arrow, which location shows the deflection of the wind that's due to Coriolis? So only one of these actually makes sense. If I trace this, that's making a left. That's not right. If I trace this, that's making a right. let's just double check. If I trace this, that's making a right, but I'm in the southern hemisphere here. These should be left-hand turns. So these three arrows here were all incorrectly drawn. This is the only one that's showing north to the right. There is no south to the left turns, so I'd go with choice A. Which one do you think here would show a dashed arrow, wind direction, northern hemisphere, north to the right? So that'd be choice B. All right, describe, let's move this one out of the way here. Describe the apparent direction of movement of the constellation Hercules and Perseus during 2 hours. 2 hours. If 1 hour I wait 15 degrees, the Earth will rotate. So 2 hours, it's going to rotate 30 degrees, right? 30 degrees. Which way is it going, okay? 9 p.m. to 10 p.m. Do you see how it was here and now it's up here? So it's going to the left. Circle Polaris on diagram 2 provided above. So you need to be able to locate where is Polaris on some of these things. Drawing the Big Dipper, sometimes you have to be able to do that. Okay. Here's the 7 stars of the Big Dipper, the best I can do. So there's Polaris, and there's Polaris. These two right here point towards Polaris. Observation, evidence that the Earth rotates. Just anything about Foucault or Coriolis? Yearly? No. Rotate is a daily change, so that I get rid of that one. Constellations from month to month, that's a long-term change. That's not a rotate. These are revolution questions. Length of the shadow by the flagpole changes from season to season. Season to season's a long-term thing. I almost thought it was this because your length of the shadow does change based off of the rotation, but once they said season to season, that's a long-term change. And then you've got the pendulum, so that's it right there. Choice D. What motion is responsible for the regular seasonal changes of the seasonal long-term orbit, revolve? Do the stars orbit the Earth? No. Do the stars orbit the Sun? No. Does the Moon orbit the Earth? Yes. Does the Earth orbit the Sun? Yes. Which of those two make different constellations visible? We choice D. And then this diagram really shows that nicely. So let's take a second and look at this here. The question is fairly straightforward. What date is paired with two constellations that can be seen at the sky at night? So here's what we got to remember. Let's get my black pen here. Okay. If I look at March 21st, okay, this is the daytime because this is the side of the Earth facing the Sun. This is the nighttime. So the Earth on March 21st can see the night sky, could see Leo, Virgo, and Libra. Okay. On August 21st, because the Earth goes around the Sun, here's the daytime. So the nighttime on Earth, you can see Pisces, Aquarius, Capricorn. Okay. In March, you can't see those because, well, you're looking past the Sun. The sky is lit up. Stars aren't visible. In December, here's the daytime, here's the nighttime. You can see different stars throughout the year because the Earth goes around the Sun, orbits the Sun, revolves around the Sun. Now this is fairly straightforward. Which ones match up properly? May, where's May? Libra, Scorpius, Sagittarius. No, Taurus didn't make the cut. November, where's November? Aries, Taurus, and Gemini. No, Capricorn didn't make the cut. August, Pisces, Aquarius, Libra, Virgo. No. February, Leo and Cancer. February, Leo and Cancer. February would be our choice there. So whatever is on the side of the Sun, the side of the Earth that's not facing the Sun, is what you can see throughout the year. So long-term changes, it's an orbit, it's a revolution. Pretty much the same diagram. Okay, the Earth's located. What two constellations are visible to an observer at Earth at midnight? Take a second, try to answer this one without me walking you through it. So I can see Taurus, Gemini, Cancer. Gemini and Taurus would be choice B. Motion causes different constellations on July versus January. So they're talking long-term changes there from July to January. It can be a little tricky. In one night, the constellations all go through the sky. But if you're talking 6 months apart, it's automatically a revolution question. And it's the Earth in its orbit. This is a one-night question. This is an Earth rotate question. They could have asked what makes these changes happen, what Earth's motion. This would be a rotate. How many hours is the Earth rotating? Well, 90 degrees. 1 hour I wait, 15 degrees the Earth will rotate. Hey Siri, what's 90 divided by 15?
6.
How many hours was the lens kept open? Well, it looks like 30 to 90, 60 degrees, 300 to 360, 60 degrees. Hey Siri, what's 60 divided by 15?
It's 4.
What time of day is it at point X? Well, let's look. Here is the sun. So if the Earth is spinning this way, okay, this right here is sunrise. This would be 6 a.m. As the Earth is spinning, this would be noon. The Earth is spinning, this is sunset, 6 p.m. So as the Earth is spinning, this would be midnight. Diagram shows the motions. The moon's going this way. Everything goes the same direction. So the Earth is spinning this way, and the Earth is orbiting the sun this way. They're all going in the same direction. Which one shows that? Looks like choice C. Time of day. So sunrise, noon as the Earth is spinning, sunset, 6 p.m. You hungry for a little lunch, Yuri? You want a Vegemite sandwich? Okay, go on. Better take a left-hand turn, because they're in Australia, those Vegemite sandwiches. Bit left, southern to the left.